Welcome to Elixir Mix, your weekly Elixir podcast, talking with members of the community. My name is Mark Erickson, and on our panel today, we have Josh Adams.
Hello.
And today we are joined with our special guest, Martin. Martin, can you say hi and introduce yourself?
Hi, everyone. I'm Martin, or Wiebe-Marten Wijnja, as I'm called by my Dutch name. But usually I just introduce myself as Martin because that's something that people can actually remember. I've been programming for quite a long time. I started when I was 9 and have been doing mostly professional web development stuff starting when I was 12. And I've been in the Elixir community now for about 3 years. You might know me from the Elixir forum, where I am a moderator also for like the last 2 years. And I am maintainer of about 20 packages on HexPM right now.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code DevChat at Sentry.io to get 2 months free on Sentry's small plan. That's code DevChat at Sentry.io.
Yeah, I have followed you in the community for a really long time, so it's really nice to meet you.
It's nice to be here on the show.
Well, like Paul Harvey's The Rest of the Story, we wanted to catch up with Martin about his Elixir Conf EU 2019 talk that was titled An Adventure in Distributed Programming. So at the time, they were in the middle of building a distributed Elixir system, and we wanted to hear how things have gone and kind of what he's learned from this. And so in preparing for this, it's already been an interesting discussion and lots of stuff I think it will be helpful for people to think about and learn, and we can discuss. So I'd love to hear. So first, why don't you tell us where you work and what kind of problems you're solving?
So I work at a small startup company called Resilia here in Groningen, a city in the Netherlands. And we like to tackle problems that either require distribution, fault tolerance, or decentralization. We've also done some things with Bitcoin and Ethereum in the past. And these are the problems that we like to tackle because they're very interesting.
And in your presentation, I really liked how you talked about, I think it's great to just kind of open up with some of the fallacies of distributed programming. Because what I think is so interesting about this, it's like a list of about 8 things that people often just they're not even in your mind when you're thinking about building your system. Because I would just say, like when you're typically building a distributed system or something where we say, hey, I want to have multiple nodes in a cluster and they're going to be connected together and they're going to be aware of each other and work might be shared. Oftentimes there's just aspects that we're just not even thinking could be a problem. I was wondering if you could just kind of lay out what some of these potential issues are for us.
Yeah, so yes, I started with these 8 fallacies of distributed computing on my first slide, or actually the 0th slide that I already had open before starting with the actual presentation. Because yes, when most developers are used to programming on their own machine, on a single system. And I actually think that it's easier for a person who has not that much experience with programming on a single system to get started with programming a distributed system. Because on a single system, you can take so many things for granted, like not having to care about latency because everything is right there. And not having to think about that you're running multiple versions of the software at the same time. And also, usually all the parts of your computer work and you get an instant notification if something breaks down, which is also not true if you have multiple things connected over, for instance, the internet. So those kinds of problems fallacies, those kinds of things all happen when you're talking about distributed systems. And you have to keep them in mind, be really mindful of them, because it is so easy to forget that they are there.
Yeah, like one of those that comes up, I think it does come up a fair bit when we talk about Elixir, is that the network is reliable. Because we talk about the idea of a split brain problem, which we'll talk about more as we go on. But just that, a network interface could fail on a virtual private machine that your software is running on, or a misconfiguration of the network could happen, just where something happens and you just take it for granted that these are connected and they're going to stay connected. And the bandwidth between the machines, I don't even think about what my bandwidth is. I might, if I stop and think about it, think, oh, it's probably gigabit Ethernet. But is it really? And then how much communication is going across? Is it shared? Is it a shared tunnel, a shared pipe? So lots of these things, I think we just take for granted. And especially when we're coming from the perspective of like, I'm building a Rails app or a PHP or something where the machines aren't even connected to each other. They're not even aware there's no distribution. It's just a stateless requests are being served up.
Yes, exactly. And this is very interesting because yes, it's even more true for systems like PHP or Rails, or just having a single app running in a language that mostly does everything in serial, so not in parallel. But even in Elixir, when we're running a system in Elixir with multiple processes but on the same machine, we usually don't think about network latency because messages appear to us instantly in the mailbox of a different process. Like the time delay there is negligible, and this is not the case anymore in a distributed system. So yeah, it's difficult to keep these things in mind, of course, because you have to think about them consciously, and they sneak up on you.
Yes, and I'd love to hear any stories you have about where you might have experienced one of these, where it's like, oh, you just, I don't know, like any experience where you've felt that problem kind of surface and you're a little bit surprised by it.
I have an interim question that can maybe give you some time. Do either of you know of any testing tools that are made to make it easy to test how your system holds up in the face of these various fallacies?
Yes, I know of 2 tools-ish. I have not used them myself yet. I very much look forward to at some point tinkering with them. I know there is TLA Plus from the top of my head, which is a system where you can, I think Chris Keatley mentioned it in his Elixir Conf EU talk, actually, but I'm not entirely sure. Anyway, it's a system. It's a small programming language or description language in which you can, on a conceptual level, describe the different parts of your system, so the different distributed parts, and then it will try all the different possibilities it can come up with to show you that there are still race conditions in your conceptual idea of how the system should work. Of course, it still only works on a conceptual level, so even if it says everything is fine, then you can still make mistakes actually implementing the system. But that's one case I know of. And I believe there is another party that is implementing something that can actually, yes, it's the Erlang quick check implementation, which is able to, I think, it is able to do crazy things with like blocking a scheduler to introduce delays and reordering messages to show you to generate potential edge cases that your application might not handle.
Yeah, very cool. I've not used quick check proper, and I would like to.
I will mention another tool that I think is just hilarious. It's on GitHub. It's called Comcast, because it's simulating really crappy network connections so that you can build better systems.
Nice.
So like it will do things like, you'll start just getting packet loss. You can say like, I want to target 10% packet loss or a latency or just, intermittent connection failures, all this kind of great stuff that you might have to deal with in like, the actual internet. And so it lets you kind of simulate some of those things on your local machine. It works on OS 10 and Linux and yes, OS X, I guess. Yeah. So anyway, so that's a fun one. It's not Elixir specific. All right. Well, one of the other interesting questions I think I've heard mentioned multiple times when we talk about distributed systems is the Byzantine general problem. And I liked it in your slides. You had some nice pictures, with Star Wars Jedis to help visualize this. I think it's worth discussing just kind of what this problem represents and how we can kind of go about thinking about it.
Yeah, so in a more technical abstract sense, the idea is that you have two nodes, and you, in the metaphor, you call them the two generals, and you want these nodes to be in agreement about something, to make a decision together, so to be in consensus. And it turns out that this is really difficult if you cannot be sure that the communication between them is reliable. Because if these two people or these two software nodes try to send a message, so node A sends a message to node B about, hey, I think we should do this, or hey, I think I've seen a new message that I want to store on my system, then it's not certain if this message will appear at node B. And then even if it actually goes all the way to node B and node B sees it, node A still has no idea that node B has actually seen it. And node B can, of course, send a reply or acknowledgement message back. But again, that message might disappear as well. And therefore, it turns out that there are three different cases. One where the message itself is lost. One where it actually reaches B, but the acknowledgement message is lost. And finally, the case where everything happens like normal and both messages are sent. But only in this last case are node A and B actually sure that the other party knows what they did. But in those earlier two cases, in one of the two, node A doesn't know what node B does, and node B doesn't know what node A does. But in the other case, node A doesn't know what node B does, but node B has made some decision based on the information of node A. And the problem is, of course, that node B would also like to be certain that node A knows that it saw the message of node A. But then you can keep on sending these acknowledgement messages forever. And at some point, maybe one of them might be dropped or not. And only if all of them happen to reach the other party, you are certain that you have reached a joint decision. So yeah, this is really difficult. And that's the Byzantine generals problem in a nutshell.
Yeah, I think one way of kind of visualizing this, like, say, Josh, you're going to help me out here. All right. So if I say, Josh, let's get on for a podcast, that's my message I'm sending to Josh.
Right on, man.
Josh may never receive that message. He may never hear that, that I said, hey, let's get on for a podcast. But otherwise, so maybe he does hear it and he sends back a message to me, but I never get the message. So he thinks that we're on the same page, but I never get the message. And then the other one is where I actually do get the message, right? So then everybody knows. But no, there are three scenarios, and what's the other one? I'm forgetting one.
Yeah. So there's one. The nice scenario is, of course, when you see each other's messages, and then you know, yes, we will be able to meet each other at this time. But then there's one scenario where you send the message to Josh, and that message gets lost, so Josh doesn't know what to do. Okay, and there's one scenario in which Josh does get the message, but you have no idea if Josh has actually seen it or not. Mm-hmm. So in half of those cases, Josh will do something without you knowing. And in half of the cases, you might expect Josh to do something, but Josh actually has no idea that it should happen.
Yeah, so it just becomes complicated. And then you're like what you were talking about before, where you have these multiple sets of acknowledgements like, well, I never heard him say that he's going to do it. So do I have to keep sending him, do I have to keep sending the message to make sure he knows? But like in the Byzantine generals situation, you imagine even like further distributed systems where they are, like you imagine generals preparing for war, and they're sending like courier messengers, and they're sending messages like by horseback miles to get to this other person. And obviously, you can't get an acknowledgement back to say, yep, I'm totally on board with you. Everything's set to go. It's not as easy. So yeah, it does become complicated, and especially when you start to introduce more systems. So it's not just two. But yeah, so like that is. So I know one of the things that you talk about in your presentation, and that I think we're all love and excited about in the Elixir community, is CRDTs.
Yes,
we love them because Phoenix implements them, so we don't have to actually understand them, right? But so if we do want to build systems that might have this problem where they might we don't know that everyone has the right message, and maybe one set of nodes has a different set of messages than another set of nodes, and eventually they need to kind of sync up. CRDTs are a better way of providing that ability. So maybe you could just kind of give us a little background on what a CRDT is.
Yeah, so before I do that, the idea behind this is, of course, like when Josh thinks you will do the podcast in one moment and you're not sure if Josh knows that, and maybe you already sent another snippet of information as well. Maybe Josh has some information as well. Now you both have different types of information, and there might be a conflict there. And of course, hopefully at some point, you will be able to communicate with each other again, and the messages that you send each other will arrive. Now you suddenly are aware that you have conflicting information. And of course, the solution is that you resolve this conflict by both now choosing, for instance, the same date to actually record the podcast on. However, like making the same choice here is difficult, and it really depends on the data you have, if this is even at all possible. And CRDTs are a mechanism that allow this or abstract this away from you a little bit. You still have to be able to structure your data in such a way that it is possible to resolve this conflict for you. It's not possible with all types of data, but in many cases it is. To give a really simple example of a CRDT would be if you would like to count how many visitors your website has had in total while it has been running. So your simple site might, of course, run in a single server, and now you can just keep track of a counter. However, if you want to run the same system in a distributed way, and you want all of these instances to be able to show the current counter, then they need to know not only their own counter, but also the counters from all the other nodes that are running. And of course, this is fine until the network connection is suddenly not reliable anymore, and you don't know everyone's counters. Now you're showing outdated information. But if afterwards the network connection is reestablished, you can still say, oh yeah, well, you will never get fewer visitors to your site. So I can just replace the value that I still have here of your counter with any later counter value I receive from you, as long as it's higher, because I know that the value will never decrease. So that is a very simple example of a CRDT, which is it's usually called the counter, where you count things up and the value can never get lower. Sometimes you might show a stale value that's slightly lower than the actual value, but in this way you can synchronize later on when the network connections have been established.
And I think one of the best ways to think of, one of the ways I think is very helpful to imagine these counter ones is to say, I'm doing operations that aren't saying set the value to 100, because I can have multiple competing messages sent from different systems that are saying, oh, set it to 150, set it to 200, set it to 50. You know, they can be all over the place. It'd be more safer to say, increment the value by 10 or increment it by 1. And then by just math and commutative properties, it just aggregates. And you can just say, okay, well, one of them decremented the value by 6 and one of them incremented by 10. And just all nets together. So eventually they all sync up. So you have to think about some of your problems and the way you're modeling your data differently, to think, how can I break these operations up into something that is easier to resolve and bring together?
Yes. So currently, and this is really the thing, and also the problem, or one of the main problems, is that if you want to use CRDTs, you have to massage your data structures to fit them, and you have to make choices here. But it's good that you have to make these choices, because these choices you would otherwise have to make on the fly while your production system has had a network problem with half of the nodes, and now you're like, oh no, I have 2 different versions of my database. How am I ever going to reunify them with each other?
It's much nicer to have to fix those problems on the front end, for sure.
Yeah. Just do it with a little JavaScript snippet. Yeah, that's even better. But so currently, it means that if you're working with integers, then you can take the cumulative sum of all values so far. You can also get numbers, count up. You can also count down. You can work with sets. You can work with maps. or values inside maps. However, if you want to do any other types of operations, like if you want to store strings, for instance, you have to decide when you get a different string, okay, do I keep the old one or the new one? And the same thing with maps. So you can essentially say, okay, I can add any new keys to the maps and take the merge of those maps all the time. But if I alter what's below one of these keys, then that depends on what data I store there. So if it's a counter again, then not a problem. But if that is a string, then I have to decide, well, do I keep the old one or the new one? So yeah, you have to make many decisions like that based on your data. So not all data can work with CRDTs.
It's true. And I think one of the ways I've kind of approached, like I have built a system. It was for my own experimental use. I was thinking about building a product that I was going to sell, and then I did some more market research and realized I wasn't going to. But it was built with CRDTs and CouchDB, which we're going to talk about also. But one of the things I learned was the idea of how can I express these operations. And so like one of the CRDT type of operations or types of CRDT types is an operation. And how can I express an operation to say, I want to change this product's item description to this text. And then, along with that, you're saying, identifying which node it's coming from and a timestamp relative to that node. So all these kinds of pieces of information can help you resolve conflicts should they occur. And that's one of the fun things is we call them conflict-free replicated data types, but they are not purely conflict-free. So you still have to have a way of reconciling. So one operation might be to say, I want to delete this item from my database. And a separate operation that was done prior to the delete or separately when they were separated and there's a split might have said, edit this item. And so when they come together, I have to figure out how do I resolve that? It's like, oh, well, if I have an edit and the thing isn't there, I'm just going to say, throw it away. But the whole point is we have to think about them. We have to take them as part of our design. So it does become a very interesting set of problems.
Yes, and I think it's really nice to be able to make these conflict resolution decisions up front. And in that way, during runtime of your system, they will be actually conflict-free. Because, yeah, it's better than waking up in the middle of the night to a burning server or group of servers.
Yeah. We had 2 MySQL servers that were master get net split from one another because the client paid a highly expensive Oracle person to come down and break them for us. And I think about that a lot when I think about CRDTs because that was a miserable week.
Yeah.
Ouch.
One of the biggest pain points that I find as I talk to people about software is deployment. It's really interesting to have the conversations with people where it's, I don't want to deal with Docker. I don't want to deal with Kubernetes. I don't want to deal with setting up servers. I don't, all of these different things. And in a lot of ways, DevOps has gotten a lot easier. And in a lot of ways, DevOps has also kind of embraced a certain amount of culture around applications, the way we build them, the way we deploy them. And I've really felt for a long time that developers need to have the conversations with DevOps or adopt some form of DevOps so that they can take control of what they're doing and really understand when things go to production, what's going on, so that they can help debug the issues and fix the issues and find the issues when they go wrong and help streamline things and make things better and slicker and easier so that they'll more generally go right. So we started a podcast called Adventures in DevOps. And I pulled in one of the hosts from one of my favorite DevOps shows, Nell Shamrell Harrington from the Food Fight Show, and we got things rolling there. And so this is more or less a continuation of the Food Fight Show where we're talking about the things that go into DevOps. So if you're struggling with any of these operational type things, then definitely check out Adventures in DevOps. And you can find it at adventuresindevopspodcast.com.
I mean, it's nice that most software development teams actually already work in a slightly distributed way, because I have seen companies that essentially just let all programmers work through FTP on their live PHP server. And I mean, if you ever open the same file at the same time, then yeah, I mean, I would highly suspect that companies like that at some point just like implode.
Now, it's becoming in vogue to say that production is the only development environment that matters.
Yes. And I know people who would actually like live code on their production environment, which is terribly scary.
Yeah.
Unless it's not, in which case, bravo.
Yeah. And that was like with Ruby, where every request would be reevaluating and reinterpreting it. So.
Guilty.
Yeah. So let's just talk briefly about, so say we do have a situation, and I think there are situations where we can build systems that don't have to have all of these problems. They may still have some of them, but we can really mitigate a lot of them. So first, let's just talk about, Josh, I know you've done this in the past too, but some of the ways we can bring cluster or nodes in an Elixir Erlang cluster to be aware of each other, to have the beams connect. And you talk about these in your talk, Martin, and one of them is Lib Cluster, and the other is Partisan.
Mm-hmm.
And
Yes.
I don't have any personal experience with Partisan. I've heard good things about it. But I currently use Lib Cluster, and I'm curious about both of you, what you guys are doing.
Yeah, so both of them are a replacement for the built-in Erlang node distribution and communication system. And the Partisan tries to use a different way where, so it's better to, if you want to compare them, the built-in way of clustering opens a connection from every node to every other node. And this means that when one node drops out, all other nodes are still connected. But it does mean that at some point, like for every node you open, you need n more connections. So it grows with it grows exponentially fast. I think it's the factorial of the number of nodes of connections that you have open. And this is why many people say that if you want to run more than roughly 100 Erlang nodes, then the built-in Erlang distribution stops working, because you're only ever, the system is then busy constantly with sending heartbeat messages from one node to the other. Like every node is constantly trying to tell every other node that it's still alive without actually doing any useful work. And Partisan tries to change this by not having every node connect to every other node, but instead building a mesh where every node is connected to roughly the same number of other nodes. So say every node is connected to 4 other nodes, and then you can build a square or a cube of these nodes visually, like mentally, and you can see that if one of these nodes drops out in the middle, you can still route messages around them, but all nodes only need these 4 or 5 open connections at a single time rather than having 100. And this allows, especially when you get a system with more higher numbers of nodes, for the system to remain more stable and still be able to communicate, even if you have many nodes open at a single time.
I'm hoping to be able to use Partisan very soon. So this is fun. Partisan also has a high par view implementation, which is neat.
What was that again? A high what?
High par view. So like hybrid partial view. It has one strategy you can use that's just kind of more resilient to nodes going offline and coming back online.
And so I did want to talk briefly about Lib Cluster.
Mm-hmm.
So it is by Bitwalker, Paul Schoenfelder. He's very helpful and very involved in the Elixir community.
Yeah, he's a great guy.
Yes, and he was at Elixir Conf and presented and talked about some of the exciting things they're doing. So anyway, so some of the things that I wanted to talk about with Lib Cluster is it has multiple ways of, I think they're called adapters, but multiple ways of using it and configuring it to have it help connect your nodes. And so for me, like I'm running my Elixir system in Kubernetes.
Mm-hmm.
And so I'm using the Kubernetes, they call them strategies. That's what it is, cluster strategies. And so I'm using the Kubernetes one. So Lib Cluster talks to Kubernetes itself and queries it for the different labels or things that are set. And it says, it's just configured to say, I should ask for other nodes or other pods that have the same name. They're labeled the same way, as you kind of give it that string of what it's looking for. And then it can connect to them, and it initiates that. So what's really handy with that is you don't have to be aware of DNS names, IP addresses, or anything, because with Kubernetes, they're constantly changing as you bring up and down different pods. So
yes,
that is one I find a lot of benefit from. It works really well for me.
Yeah, that's really nice, because in the built-in EPMD is the system called, and that's built in Erlang. You have to do all this configuration yourself, either in your configuration file, or of course you can open a console and connect it to your running system and configure it from there. But neither of these is really nice because yes, it's really cool that these things can be automated now. So yeah, I think Lib Cluster and Partisan both have a slightly different goal in mind, but both are really worth looking at.
True. And it might be that one fits your needs at one point in your development process and your scale. And then as you go like higher, like towards something that more partisan better fits your needs, then that might be when you kind of transition and start to grow into that. So I don't know. It's something to consider. Another thing that we talk about with Elixir is just how awesome it is that it is distributed aware, that I can have a PID and I don't actually have to know what node that this process is running on. And there's a couple things that you mentioned in your talk, which I really enjoy. I've used a couple times when building like a multi-master aware kind of system where you had leader elections. I was using gen server multicall. And when I mentioned it to other people, like it seems a lot of people I run into haven't heard of this. So multicall, and then the one is abcast or abcast. I'm not sure how you pronounce that. But why don't you go ahead and just kind of tell us what multicall is, how it works, and kind of what makes it special?
Yeah, so the idea behind both of these functions is that you can talk from one node to all other nodes in the cluster. So you can pass them a list of nodes, and I believe it defaults to just all nodes that you have in your cluster, and say, hey, I want to execute this this module function argument tuple on all nodes that are in my list, or like all nodes I have. And then multicall collects the results for you afterwards, so it's synchronous, and abcast just runs the functions without caring for the results. And multicall does something special as well. Rather than only collecting the results, it also will tell you what nodes did not respond properly to your request, which can help you to figure out problems with your network interface. So these are rather low-level tools, but they are really nice if you're building a system where it makes sense to drop down to this layer of abstraction. And this is how many of the other systems, like for instance Phoenix PubSub, that work in a distributed way, are under the hood implemented. So yes, it's definitely something that is nice to look at and tinker with a bit, because it can improve your understanding of Elixir and how it works.
Yeah. And so like the situation I was solving was I had so I'm running the same set of code on each node in the cluster, and say I have 3 nodes in the cluster. So it's the same set of code. So I have a gen server on each node that has the same name. It's a named gen server. And I'm wanting these to coordinate about who's in charge of, who's the leader for performing certain operations. And these are, this is that Byzantine general problem where it's like, I want to know that they know that I know that they're in charge, kind of a thing, right? It gets goofy. But so what multicall let me do is I can just say, I want to send this message to this named gen server process everywhere in the cluster. And and like Martin, you were saying, like it'll come back and tell you, well, I didn't hear a response from this node. Maybe it's not running the code. Maybe that's fine, but it does aggregate all of those results back, and I can see, yes, the message was sent and I got an acknowledgement. It handles that receipt. That let me just have these different gen servers kind of coordinate with each other and kind of give their status, and then kind of coordinate a leader election. And then one of them kind of is in charge of running whatever processes or jobs it's supposed to be doing. And then when that gets, rolling deploy and one is taken out, then new leader election happens. So, but multicall is a great way to do that. Just a great way to have communication between named gen servers on the same code base on multiple nodes. So I love that one when I found it, and I was like, wow, that's so cool. And it's built in. That's so great. So I'd love to also, in some of your discussion on your presentation, you talked about Amnesia. And when I first came to Elixir, I learned that Amnesia was this database that was built in and available. It's like, wow, that's so cool. I want to use it. And then I realized, wow, that might not actually be what I want. It sounds like you had some similar kinds of explorations with Amnesia. I'd love to hear kind of what happened there.
So when I started using Elixir for the first time, and I found out that there are all these great applications that come with OTP or with the Elixir standard library, I was super excited. And then you hear these interesting things of people saying, yeah, you don't need Redis anymore. You don't need cron tasks anymore. You can do all of these things inside the Beam. You have ETS tables, but if you need a slightly more mature solution to store your data and maybe perform some more complicated queries on them, you can use Amnesia. And it's great. And even if you scale up to a cluster and you have a distributed system, you can continue using Amnesia because it's built for that. And I was super excited. And of course, like many people, I think that started with Elixir when I tried building a couple of hobby projects and like completely replace all the components with either custom built parts written in Elixir or some libraries that other people had written. But it was like, yeah, I'm only going to use the Beam now. And like, you don't really need an operating system anymore, only a really, really thin layer. And then let's build a whole new world inside the Beam. Well, of course, that is not very practical because for one, there are many systems, many mature systems outside the Beam that are really well worth using. And for another reason is that we have to talk to the rest of the world, and we have to be a nice citizen, and it's just not practical to do this because there's so much existing technology already out there. But yeah, with Amnesia specifically, we started using it in Planga, which we'll talk about in more detail probably later. Which was also the subject application of my presentation. We started using Amnesia in this project because at first we were thinking, okay, we're going to build this application, a chat application, but we're not entirely sure yet how we should store the data. So rather than committing to a certain database, we said, okay, what about keeping this inside the Beam? Because then we can make this choice later and like delay it until the latest possible time. Which is nice because hopefully then you have more information about what you actually need. But it turns out that Amnesia has a lot of peculiar restrictions itself. For instance, you can have tables in there, but if they grow beyond a certain size, I think it's 2 gigabytes, then it won't work anymore. And you have to split up your tables in multiple tables. And Amnesia can do that for you, but you have to handle that yourself. It provides a couple of callbacks, but you have to implement them yourself to make sense for your system. And this was only one of many things that it sort of provides with callbacks, but you have to implement it yourself. Another famous example is that Amnesia doesn't do the conflict resolution of your data for you. So if there is a net split, so if there's a network connection problem between your different nodes and the connection comes back, then Amnesia will suddenly cry and say, hey, I have a conflict now, I have corrupted data, help, you need to fix this for me. And there's no built-in way in Amnesia that does this for you. It says you as a developer are the one that knows what makes sense for your data, so you have to build it yourself. So instead of having a nice simple solution that we could use until we moved over to a different system, it turned out to be more of it is its own quirky thing, and you have to build many pieces of the puzzle yourself to make it actually useful type of deal. And that was a bit of a bummer. So it's really nice if you have a really large company and you have a lot of data and you can, and it makes sense to have the time investment to spend this extra time programming to make it completely tuned for your application. But it's not a really useful, nice tool out of the box for larger distributed systems.
Right. And so I dropped in some links to Amnesia Documentation in the show notes, so please check that out. One is the original or the official Erlang documentation. Another one is from Learn You Some Erlang for Great Good from Fred Hebert. And what's interesting in here is kind of being aware of what Amnesia was designed for and created for. And like in his write-up, he says, Amnesia is not meant to replace your standard SQL database. It's not meant to handle terabytes of data across a large number of data centers. It's rather made for small amounts of data on a limited number of nodes. And the practical limit seems to be around 10. So it's kind of just being aware that this is a tool that is available. It has a use case that it is better suited for. And I think, from my understanding, some of the use cases were around config that might be shared among a set of nodes, but that config is fairly static. That was one of those situations where I think it might work really well because it sits on top of ETS and DETS, or just distributed or disk-based ETS. I'm not sure if it's distributed or disk. I forget.
It's disk.
Okay, disk, yes. And it's just something to be aware of. I know, as I mentioned, it was something that I kind of thought was, oh, I can just use this for everything, also. So it's, just kind of keeping in mind there are use cases where it might be more appropriate, but for the most part, what you're thinking of probably isn't Amnesia. That's probably not the right tool for what you're probably thinking of that you would need in your application.
But it might be really cool for home automation purposes.
Definitely.
Right. Yes. Like doing something at home, experimental projects. Yeah. Play with it. Have fun with it. So I would love to talk about briefly some of the other distributed DBs that you were mentioning in your talk, and just so people can be aware of them and what they exist.
So when we started building this application, I looked into 4 different well-known distributed databases. And it turns out that it's really nice that there's more than one solution, more than one tool out there, but they all have their own quirks, their own features, and their own drawbacks. So Amnesia, we already mentioned. Then you have Cassandra, which is, I believe, written in Java. And Cassandra is actually the tool that Discord uses on quite a large scale in their chatting system. However, Cassandra doesn't let you tune what happens when you want to do conflict resolution. So if there's a network problem and it gets resolved, then it's always the latest timestamp that wins. And this is, by the way, an interesting question. What is the latest timestamp? Because if you're talking about a distributed system, time suddenly is no longer the same on all of your nodes. So if you want to run Cassandra at a larger scale, you need another system. I think it is Zookeeper that actually handles the synchronization of the various clocks, because they're quite sensitive to. So Cassandra needs the clocks to be within a second or something to actually be reliable, to work well. So yes, for the system we were building, we didn't like the fact that it will always pick the last right wins option. Discord themselves have made a blog post about it, also describing their struggles they had with it and how they sort of circumvented the problem. But yes, that's why we didn't pick this for Plange. Then you have CouchDB, and hey, CouchDB is actually written in Erlang, which is nice because it's a great language to build distributed systems in, turns out. However, CouchDB also isn't really made to deal with conflicts. If you have a conflict, then it can either decide to resolve it for you randomly. To be exact, it does the resolution based on the hash it created, like a cryptographic hash of whatever content actual message or piece of data had, which is in essence random, like you have 50-50% chance between 2 types of data. You can opt into doing it yourself, but then of course you lose the whole advantage that you would otherwise get from such a system. And you have to do this manually after the fact. So then your nodes have to query the database constantly, to query CouchDB constantly, asking, hey, are there any conflicts here? And can we maybe resolve them now? That seemed like a bit of a strange approach, at least for the system we were building. So that's why we didn't pick CouchDB.
I did want to mention something about CouchDB, just because I have used it and worked with it, not in a production environment, so I can't speak to that. But so just to be aware of it, what it is, it's a document-oriented database, and it is multi-master and eventually consistent. So it's really cool. It has some really neat features, and there are some interesting libraries that you can use for syncing with clients to make it multi-master in that way, and they can sync up. And a lot of people have found some interesting solutions and ways of using that.
Yes.
And so I think it's a great database to be aware of for certain types of problems. And one of those kinds of scenarios I learned about, and this was also what I was modeling my problem after, is to say you might have a couch database that's kind of hosted somewhere in Central Europe, and then you have branch offices that are in different locations, and they can all be syncing up to the central server, but they don't have competing data records. Like from one office, in in France to another office in Spain, they don't have the same records. They're dealing with my own records that I care about. So there's much less likelihood of any kind of conflict, and the little bits of data that they might share is probably more static. But then they can sync up, and you can have a centralized location where they can all, so you can do analysis and interesting data processing. But it's an interesting problem, interesting tool, just something to play with and be aware of. I think it's a great tool. I love it.
Yeah, so I mean, maybe what I said sounded slightly too critical. Yes, it's really nice if you're working with a system which, for instance, might be offline part of the time. So where your client is not connected to your server. And with client here, I mean a web page or a mobile application. And then it's really nice that you can reuse your database ideas and also the format in which your data is stored, both in your web front-end application or mobile client, as well as on your server, and that this data is synchronized between them. And that's a really cool feature that CouchDB has.
Yes, I will mention, just because you brought that up with the JavaScript one, there is a library called PouchDB that starts with a P, and that one is JavaScript based. And so I was running that in a mobile environment where it actually is implemented locally in SQLite on the mobile device, but it's multi-master. And so you can just say, I'm just going to write data into this local data store, and then when connectivity is there, it will sync up and resolve itself with the backend. And when I lose connectivity, I still just working on my local data store. So that was built, for environments where you're going to have intermittent connectivity and you need to have continual service available.
We've been recording Ruby Rogue since 2011, and we've talked to a lot of people who have had a really deep influence, not only on the programming community, but also on the Ruby community. And as we've talked to these people, it's become apparent to me that we talk a lot about the things that make them interesting that they've done, but we don't really get into how they got into programming or how they came up in their career, how they got to be the person who invented whatever library or technique that they came on the show to talk about. And so I put together a show where we actually highlight these things. We talk to them about how they got into programming. We talk to them about how they got into Ruby, maybe how they got into Rails. We get a little bit deep into what makes them tick and why they are the way they are. And then we talk about what they're working on. We talk about the things that make them well known or make them interesting. And a lot of times it's the stuff that goes beyond the code that really makes these people tick and makes them the kind of people that we want to hear about. And so I put together a show called My Ruby Story. You can find it at myrubystory.com. And it's where I interview these people and just get the stories of these people and how they came into programming. So if you want to hear inspirational stories or get ideas on how you can actually advance your career, then go check it out at myrubystory.com.
So I just want to make sure that people understand that each one of these databases, they are solving a specific type of problem. It may not be your problem, but it's good to be aware that it solves this type of problem, because if you encounter a situation where, gosh, this problem is a unique problem, I've never seen this problem before. Oh, I think I know of a database or a backend kind of situation solution that might help me with that. Then that's where you just kind of want to be aware of these things, at least at a high level, so you can then investigate them later. And so I want you to get a chance, Martin, to talk about the next one, which is Riak.
Yeah, so Riak, that's the one we actually ended up choosing. And Riak is interesting. It's also written in Erlang. And Riak is interesting in that it is a key value store and that it actually uses CRDTs under the hood itself. So it started out as just a plain key value store, but a distributed key value store. And then in Riak 2, it had the option of, instead of just storing plain keys and values, to store CRDTs and describe your data and store your data as actual CRDTs. And then it will use the CRDT-based conflict resolution. And so that's really nice, because in that way, as we've talked before already about the CRDTs, in that way you can upfront describe how you want your data's conflicts to be resolved. And then that's just what happens. And we think at least for the application we are building, the chat application Planga, we think that is the best way to resolve these problems. Because otherwise, if two people send the message at almost the same time or edit the message at almost the same time, it would be bad if one of these gets lost. And instead, with using CRDTs, we can circumvent this problem.
Yeah. So why don't you go ahead and tell us a little bit about this chat application, Planga, and kind of where you were going with it, and kind of give us an update, because you talk about it in the presentation, like this is something that you're building at the time. And I know things change, projects change, business directives change. So I'd love to get kind of an update on where things are and kind of what some of the things you've learned from this whole process.
Yeah, so Planga's development started about a year ago, last year during the summer break. And the idea was we do consulting for a number of parties, and also we have some of our own applications. And we found a couple of times that we thought, hey, it would be very helpful and improve user experience if we had a chat solution in this other web application. But there was not a real tool that allows you to just plug into, to just add chat to your existing system and have it feel like it's part of the already existing system. And we've seen a couple of implementations where people were like, I really need to be able to chat here. And then they built their own half-finished, bug-ridden implementation of half of OTP. It works, but it has weird edge cases and missing functionality. And you spend a lot of time building a chat system, especially in systems that are not in programming languages or environments that are not used to, for instance, dealing with asynchronous messages coming in from various users. So building a chat system in, for instance, PHP would be much more difficult than building a similar system in Elixir. So we saw this problem and we realized, okay, we've seen a couple of instances now where a chat system that would be usable would be really nice. And it would be nice if people don't have to build it themselves all the time. So we thought, okay, we can provide this as a service. And that is how Planga was born. And then, we had been developing on the Planga for about half a year. And then the call for presentations for Elixir Conf EU started. And I thought, okay, this is really interesting to talk about, because we were investigating how to change this into a distributed system at the time. And the reason, of course, we wanted to do distribution at that time was because we had one potential large client that wanted to possibly handle many users connecting at the same time. So the idea here was they wanted to build a service where that allowed for video streaming, where then many people see the stream at the same time and are able to talk right next to the video screen with one another. And that kind of traffic is very irregular, and you have suddenly very high numbers of users connecting at the same time. So that was why we thought, okay, we probably need to be able to scale up and down really fast when these kinds of this kind of traffic will happen. And it seemed to happen in the near future. So that was why we started investigating how much work it would be to switch over to a distributed system. And that's why the presentation, also how the presentation was born, because we learned a lot during those three quarters of a year, so 9 months of working on it, because we had some experience in doing both distributed and decentralized systems before, but this was the first distributed system that we were actually building with Elixir. And you hear these very cool stories where, so I mean, the pitch that people often tell other people when they talk about Elixir is, oh, this is this new language and the syntax is really easy to learn and get started with. Oh yeah, and if you then suddenly want to run it on multiple computers, you just start it up on a second computer and you connect the nodes and you're done. And it turns out that in practice, it's slightly more involved than that. I mean, it's still a lot better than other tooling in other languages or environments out there. But yes, it's never that simple, you know? So that was what the presentation was about. And it was a lot of fun presenting at Elixir Conf. And I had much positive feedback and responses. And then after that, we continued working on Planga. But unfortunately, it turned out that this particular client with a video streaming solution, it turned out that project wasn't going to happen, at least in the foreseeable future. So rather than still trying to continue on with moving to a distributed system, it went back to the shelf of longer term future, because I mean, it's a great feature, and personally, I would love, of course, to go there and finish it. Most of the work is done. However, it's not the main priority at this point. And building and maintaining a distributed system is a lot more effort than just building a normal system. Of course, we do still want to have the possibility to move it over to a distributed solution as soon as we need to. And that's why during our current development, we try to keep this path open to structure or data storage or data structures in such a way that we can move them over to a CRDT-based system. But yes, we are unfortunately still not using React in production at this time.
I have never used React in production, and I would like to.
Yeah, so I also the same. I've heard wonderful things about it. Does have a little bit of a troubled history, not because of the technology, but more of the shepherd was the company Basho. And they ended up as a consultancy, I believe, and they ended up having some financial difficulties, and they're gone as an organization. But the software has kind of been released and trying to. I'm not sure how well it's found footing with a new home, but so it is good technology, but it is. I think it needs a little bit more love. Isn't that kind of the experience that you've had with it, Martin?
Yes, definitely. Because I mean, there's still like the documentation on Basho's website, which is still up, is still available, and it's quite decent. However, some of the pieces there are missing. There are not that many examples. And for instance, we wanted to make it easy to run this chat app, Langa, not only for ourselves, but also for other people, because we also wanted to provide it as an open source system and allow people to host it themselves, especially if they have, for instance, if they have confidential data, messages, they don't want to share it with a third party, we totally understand. However, so we try to run React as a Docker, in a Docker instance. Another reason was because it would make testing easier. However, the Docker image is one of those things that definitely needs some love to make it easier to run it. I have fought many days with the Docker image of React.
Interesting.
As who is shepherding React right now, by the way, Bet365 took over React because they are using it at large scale to power their betting software. There's some talk, I think from 2013 or something, available where they explain how they are using it and how they are structuring their data as CRDTs. I think it's really interesting. So yes, there's a new shepherd, and there is still development going on React. I think it's mostly one guy that does maintenance right now. But yes, it's mostly I think it hurt the reputation of the database that Basho had to went bankrupt, because and it's a bit unfortunate, because as a tool, I think React is great, and it has some very unique features that you don't see anywhere else. So I really hope that React itself keeps improving and the tooling around it keeps improving to make it easier to use, and that people get more excited about it again.
Yeah, and even if you don't use React proper, React Core is very cool. It's sort of the fundamental distributed systems framework for React.
Well, cool. Thank you for giving us an update on kind of where things went. And I know how, I've worked in startups and just where kind of pivots happen and changes happen. And we don't always get to hear the rest of the story and kind of what happened and kind of what some of the learning that ended up coming out of those experiences. So thank you for sharing those things.
You're very welcome. I think it's really helpful for developers to know about each other's experiences, and it's a bit weird with conference talks that it's always this snippet of time, So yes, I think it's really really helpful, and it's really nice that you reach out to me to talk about this in more detail.
Our pleasure. Well, is there anything else we want to talk about before we go to picks? I remember one thing we were talking about in the pre-show. I wanted to hear about how you got started with Elixir.
Yes. So the slightly longer version of my story is I started programming already at 9 years old. At the time, I was in elementary school, and we had this software on the computers there called SuperLogo. And that's a very basic programming language where you control a so-called turtle, or you could see it as a tiny virtual robot on the screen, and you can give it commands like move forward 100 pixels and turn 30 degrees to the right, and then move forward again. And it also has a pen, so you can make it draw beautiful shapes. And so I was using that for a couple of months. And then one of the new teachers saw me working, doing that. And he was like, oh, I have learned a bit of HTML. Would you like to, let me show you how that works. So he opened up Notepad on this Windows XP computer. And he typed in a basic HTML page, and he opened the browser and he opened the same file and was like, look, and now the background is green. And if I change the text file and save it again, now the background is red. And I saw that and I thought, that is so complex. Why would anyone ever use that? If I write my SuperLogo program, I can compile it, and also I can like build a standalone .exe file out of it, and it has animations and everything. So yeah, who would ever go through the trouble of doing that stuff with those files and opening them in a separate browser program? So yeah, 3 years later, I started doing professional web development. At the beginning, of course, it was just building simple websites for friends and some local shops. And then after a couple of years, I started doing mostly front-end work, so JavaScript and CSS stuff, making sure the Photoshop design that someone made got implemented pixel perfectly in actual HTML. I've still been there in the days where if you wanted rounded borders, you needed to make a list item, and then you had this round circle bullet, and then if it matches the background color of your box, then you can sort of move that over, and all those other crazy hacks that you had to do to make it work with old Internet Explorers. So I did that for a couple of years, and then at some point I thought, well, this is nice, but the work is it's a bit of the same every time. So I started talking on the internet with some people, and this was also when I started becoming interested in Bitcoin. So I started working on a provably fair Bitcoin casino, and this was in 2012 when there was no regulation at all for these kinds of systems. I was 17 at the time, and I had a blast just working remote with one person from Canada and one person from Romania. And it was really interesting to work like this together. And we built a beautiful website, and it worked well for a couple of weeks during the alpha stage. And then at some point it got hacked because there was a back-end bug, and the bit of Bitcoin funds that were in there were quickly lost. So it was a really, really interesting experience, and I learned a lot about programming and also about security, obviously. And after that, I started working at a small company from which Virgilia at some point grew, and doing all kinds of backend, mostly backend related work. So I started doing Ruby on Rails there. However, while all of this was going on, in the meantime, I was also still in school, like any or most kids, So I went to college, and then at some point, I started going to the university. And that's also what I'm still doing right now. So I have about roughly 3 days spread over the week of university courses, and I work 2 days a week. And I can't stop with neither of them because I like both of them too much. So the weird thing is that from the work side, I knew Ruby and Ruby on Rails. However, from the university side and from my own tinkering with hobby projects as well, I knew, for instance, Haskell already and functional programming. So when I learned about Elixir for the first time from a coworker of a company that we were consulting at, I was immediately interested. And when I read the Getting Started guide, I was like, oh yeah, the syntax does look similar to Ruby. And oh yeah, I already understand most of like tail recursion and or recursion in general, and how these functional concepts are supposed to work with immutability. Oh, but this OTP, oh, this is interesting. So I learned Elixir, or the basics of Elixir within a weekend. And then I came back in the office at Monday and I said, it's an interesting language. And the Elixir community is great. I pointed them out a typography error in the documentation and made a pull request, and it was fixed. So, and then everyone at the office said, oh, he has made a contribution to the core language already after a weekend of programming. So, I mean, that's not how I would put it, but yeah, so that's how I entered the Elixir community, and I'm so happy with all the people there, and everyone is really awesome and nice. And I have this bit of a weird position because I know a lot of information from other languages. That I often think, oh yeah, but you could also do it this way. But then I have ideas that other people don't understand anymore. So I'm in a bit of a weird spot, I think, within the Elixir community as for the ideas that I have with relation to the average Elixir user. But yeah, I love the Elixir community. I love the people at the Elixir forums, and I'm really happy to be part of all of this and to meet everyone, to be able to meet everyone at the various conferences. Yeah, I'm really sad that I couldn't go to the conference in the United States, obviously, but I will definitely be at the Codebeam Light in Amsterdam later this year. It's coming up in December, and of course in the next Elixir Conf EU as well. So yeah, that's a bit of my backstory of how I started, how I entered Elixir and the Elixir community.
Nice. Yes, I agree that the Elixir community is wonderful. The people are great. It's very welcoming, inclusive, and I just hope we can continue to stay that way and improve even from where we are. So, well, let's go ahead and move to picks. Josh, do you have something you can share?
Yes, I do. So it is a Reddit post and article / repo called Automatic White Box Testing with Free Monads. And it's really cool. It's a way of, if you write a system with free monads, which capture all the outbound effects, then you can just record the system in production, right? And then ensure that you would have had the same effects in your test suite. So that's very compelling, just being able to record a thing that's working in production and say, boom, this is now under test.
Interesting.
Yeah. Yes, it's very interesting. I've actually read that article and commented on it on Reddit, asking the author, hey, how does this compare to property-based testing? And there's a great answer on there as well. Because yes, it's a really cool idea. I don't know how easy it would be to port something like this over to Elixir from Haskell, but yeah, writing tests this way is a lot easier or easier, would take a lot less work. You would at least be certain that the stuff you're testing is the same stuff that is actually being used in your app. So that's really nice.
So this brings up a fun question. Are you aware of any sort of free monad style projects or any Elixir projects you can think of that have managed effects?
That's a great question. I think there was one person who was doing some work on an effect-based library, but I don't remember the name from the top of my head.
Okay, I'll do my own research.
Maybe it's just the one called Effects on HexPM.
All right. Well, that'll be something for the reader or the listener to do research on their own if they're interested. And the one I wanted to share is we just came off of Elixir Conf 2019 in Colorado. It was great. It was fun meeting new people, seeing old friends, and just getting to talk with people that otherwise you only have interactions online, perhaps. But it was great. And I was super impressed with the ability of the organizers did a great job. And I was super impressed with the video production that even on the first day of videos, the videos were posted the same day or the first day of conferences. And then same with the second day of conference presentations, the videos were available same day. It was like super impressive. So like, even if you couldn't make it there, you couldn't be physically present, you're able to still see all the presentations that you're most interested in. So I have a link in the show notes to the YouTube channel where you can see those videos. And there are a lot because it was a 3-track conference and there was a lot of great stuff. And I'm sure we'll be talking about more of those coming up in the future. So that's all I'm going to say about it for today. But Martin, do you have something to share?
Yes, but before saying that, I would also say huge props to the video team, because as one of the people who couldn't go to the Elixir Conf US conference, I'm super happy that all those videos are online fast. And I've already watched many of them, and I'm super stoked for Lumen, and also the Mint HTTP library looks really, really interesting. So my first pick is the book about property-based testing with Proper in Erlang and Elixir, written by Fred Hubbard, which is an absolutely phenomenal book. So I saw at Elixir Conf EU this year the talk by Tomasz Kowal about stateful property-based testing, and then I got very excited about property-based testing. So I bought this book, and it's really, really well written and clearly explained. And I was so stoked about it that I've gone ahead and started writing a property testing library for Ruby, because there is no mature solution in Ruby, or hasn't been. Like, my solution is now almost done, at least for the stateless property testing. But who knows how long it will remain in this almost done state. But the interesting thing there is that we're currently already using this now in a Ruby on Rails application to actually test some code to make sure that the ORM database queries match what we think they will do, especially when they all get combined in a complicated way. So it's a great book, and I really recommend buying it and learning about property-based testing. So that's my first pick. As for the second thing, if you haven't heard about the Global Game Jam, I've been there now. I've been a part of it now for 6 consecutive years, and it is a 48-hour game jam that happens every year, January the 31st, all around the globe. And it's a great way to do some team building with people you know, maybe your team from work, or maybe just some friends, and program something that you can throw away after the weekend. And you learn so much by doing something like that, and it was a blast every time. And what was really nice is that last time, but the time before that, we built an application that used Elixir. We built an application which was like a sort of King of the Hill game, and the game itself with the graphics was written in Unity, but then everyone was able to join at any time by scanning a QR code on their phone and going to that web address. And then their phone would act as a joystick, and they would instantly become a player in the game. And at some point, we had 14 players playing at the same time during the demo at the end. And it was a lot of fun. And what was even crazier was that during Elixir Conf last year, Chris McCord of Phoenix was talking about Phoenix is not your application, and when you should use a database versus when you should not use a database. And suddenly he had a screenshot of this game in his presentation, and I almost fell off my chair at that time. It was really, a really cool surprise. So and the final thing I have on my notes is polyphasic.net, which is a website with information about power napping and sleeping, because it's something I've been doing for some time now, and it's really nice. And I mean, maybe it works for you, maybe not, but it's a really nice way to maintain like a rigid schedule in your life. Or I personally like the early morning hours when I'm already awake, because I sleep less at night and do 2 power naps during the day. And I like to work during those hours, because then I can work uninterrupted by social media or anyone trying to call me, etc. So those are my 3 picks. Thank you for listening to my long rant here.
No, that's awesome. Thanks for sharing. All right. Well, I enjoyed our time. It's talking about distributed Elixir is a big topic, and I enjoyed just kind of touching the edges around it and kind of feeling around where some of the complexity is, and just kind of where we can start to think about things in our own systems and where we can start to perhaps explore. So thank you for doing that. And if people would like to follow you online or get in touch with you, how should they do that?
Yeah, so I'm known in most places with the handle QQWY, for instance, on GitHub and also on the Elixir forum. On Twitter, I am Wiebe-Marten, so that's WIEBEMARTEN. Will probably also be in the show notes. And you can also go to wmcode.nl, which is my personal website.
Awesome. Well, that's it for today. Thank you for listening, and we hope you'll join us next week on Elixir Mix.
Thank you very much for having me.
Bandwidth for this segment is provided by CacheFly, the world's